you're already streaming. Make sure we've got our little chat highlight thing going. Make chat a little bigger so I can see it. All right. So we are back for day 5. Let's get rid of all of this. All these tabs. We don't need tabs today. Bunch of nom stuff. I did a bunch of optimization on the day 4. So if you were here for yesterday, we did day 4, and we did it with nom and with ND array. So 2D or like a matrix library, right? Linear algebra kind of stuff. We ended up with like 300 kilobytes for our original part 1. And then I basically went through the nom parser, and I changed everything to either arrays or references or whatnot. And I removed one iteration, and I was able to drop it down to 90 kilobytes. So if you're interested, it's in the Advent of Code repo that I have. And I committed every individual thing. So you should be able to see it. At least I think it's all committed. Let's stash the dat heap changes because we don't need those. Get rid of everything over here. Copy day 4 into day 5. Day 5. So we should be good there. I will pull all of this down. Let's get rid of the heap because we don't have one yet. Our lib.rs is where we put our parsers, really. I don't think that's a huge problem. But the part 1, part 2 stuff, let's just delete part 2, and I'll recreate part 2 later. So we have the dat heap allocation profiling set up with the feature flag for compilation. This is the last thing. So let's get rid of this. Let's return 0 here. I don't know what we're doing today. We'll put test input in here again. Okay, so let's read what we have to do today. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large, opaque clouds, so it would be best to avoid them. They tend to form in lines. Hoping we don't have to do diagonal lines. This sounds like similar to what we've done in the past. Submarine helpfully produces a list of nearby vents of lines, or lines of vents, for you to review. For example, this. So here's our test input. I'm going to drop that into test input.text. Each line of events is given as a line segment in the format x1, y1 to x2, y2. So it's from here to there, here to there, here to there, here to there. These line segments include the points at both ends. In other words, an entry like 1, 1 to 1, 3 covers points 1, 1, 1, 2, 1, 3. And 9, 7 to 7, 7 covers points 9, 7, 8, 7, 7, 7. For now, only cover horizontal and vertical lines. No diagonals. Yes. Lines where either x1 equals x2 or y1 equals y2. I bet you they're going to be like, for now, only do horizontal and vertical, but in part 2, we do diagonals. Because they're like that. So horizontal and vertical lines from the above list produce the following diagram. Producing the diagram would be cool, but I don't think we are going to do that if we don't have to. In the diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point or dot. Okay, so presumably there's a singular point right there, or like there's a line here and a line from here to the end. And then there's this line going down and then the line going across. So that would be 2. Okay, that makes sense. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. At how many points do at least 2 lines overlap? Okay, so let's start with a parser, as is tradition. Let's get rid of all of this stuff. Okay, so we've got digit, comma, digit, and then a tag for the space, line, space, and then digit, comma, digit. So let's do FN. Let's get rid of this first of all. Well, it'll be fine. FN point. And we'll do struct point. X, I don't know. Let's do I32 and Y, I32. We could do this as a tuple too, so I'm not too concerned about it. And then point input is going to be a string slice. We're going to return an I result of a string slice and a point. And this will be let input x equals digit 1 input. And we're going to tag the comma and do y. But in the meantime, we're going to do a tag of comma. So this gets us 1 point, and then we, okay, input point x, y. So we can destructure construct like this. It's kind of nice. What did I mess up? Day 5, and then we test, and we expect I32? Right, because I didn't parse. Where are we parsing here? We're just going to unwrap, because if these fail to parse, we want to crash the program, and no. But because we've done that, we can't use the destructuring form anymore. So y equals that, and that equals that. I forgot to put input here. Not found in this scope. Okay, these are fine. We're going to do a separated list by new lines. Actually, yeah, we're going to do a separated list by new lines. And this is going to be points, I guess. So pub function points will do input string slice, and this will return an I result of a string slice and a tuple, maybe. So we'll call it point, and then we do basically this same thing right here. but instead of digit here, we do point. And instead of comma here, we do space, arrow, space. And then we do OK for the return type with input, and I guess I'll call these A and B. So as to differentiate them from X and Y. Because like it's point A and point B with like digit X and digit Y in them. So this will be, I'll call this points. No, I don't want to call that points. I want to call it lines. And this should return lines, which will be a vec of point. Just notice that that E is capitalized for no reason. So we test and remove semicolon. Did I put it? Where did I put the semicolon? 14. So there we go. Rust Analyzer has auto formatted. Therefore, we know we did it correctly. We have a point. So we get the puzzle input. Puzzle input is separated by new lines. So each of these is separated by new lines. Then we look for a point, the arrow and the point. Points, arrow, points. And then inside of the point, these aren't, yeah. Inside of the points, it's X comma Y. So that should be good. So we don't care about the input. Lines equals puzzle input, input. Unwrap, because we don't really care if it fails, and then I'll debug lines. And when we test this, it will tell me that I didn't put pub on. So structs are private, or items are private by default in Rust, and thus we need to put pub on this struct for it to be able to be accessible. We're probably also going to need X and Y, so I'll put pub on these so that we can access those as well. I need to derive debug, because I used the debug macro to print out lines. No board and root, because this is the old stuff. So use day, we'll call this day 5. I should call that something else. Let's call this, what do we call it? Puzzle input. We already have that import. Puzzle input, we don't need bitvec. We don't need ND-array. We do need to change the name of the crate to day 5. And then let me remove a couple of these dependencies, because we don't need bitvec. We aren't currently using itertools or ND-array. We are using nom, so I'll leave that. And then we test use of undeclared crate, because where am I using ND-array? In lib, ND-array. Get rid of that. So now we have a list of points. So we have point XY, so it's 09 to 59, 09 to 59, 80 to 08, 80 to 08. So we're good. We have all the list of everything here. Now what do we do? Now we have to iterate over this. I don't think I can collect directly, so I think that I have to manually handle this. So if I have to manually handle this, I will let points equal btree map. I spelled that wrong. Btree map. Now we dance. Hello, Alan. How are you? Btree map new, and this is going to be like point to count, and count is just going to be like an I32 or something. I guess it can't be negative, right? So we'll make it a U32. It's probably going to be small too, so it's probably not going to be actually 32. but that's fine. Let's compile this and make sure that new point is not found in this scope because we didn't pull it in. Where's puzzle input? Puzzle input is here. So point is something we also need because now we're actually using it. There's a B tree map in Nom. I need to check that out at some point. That's not the one I want, but it's interesting to know. Apparently, Rust Analyzer is not going to help us today. I don't know what's going on with that. That seems like I need to restart VS Code or something. Let's restart the Rust Analyzer server just in case. Doing good out here, just learning Rust via osmosis. I believe that's called learning Rust via carcinization or carcina. What is it called? Carcinogenation Rust. What is it? I forget what it's called. Everything turns into a crab. Carcinization. Carcinization. That's what I meant. Eventually, everything is a crab. Eventually, everybody will know Rust. Okay, so we have everything. Rust Analyzer is expected 0 generic arguments. Okay. Let's do B tree map point I32 here. So I'm just I'm making points. I'm telling the Rust compiler that points is supposed to be a B tree map where the keys are a point and the values are an I32. And then we're just constructing a new B tree map to like hold those future things. So for pint, maybe later. For point in lines, we have 2 points. We need to generate a line. How do we do this? It's going to be either horizontal or vertical, right? So maybe we do dx equals, let's do this. Let's do AB. And I don't mind, okay, so like normally naming things like A and B can be, you know, not great. But in this case, we know they're points because the types are just here, sitting here going, hey, this is a point, that's a point. So I worry about it a little bit less because like Rust Analyzer just tells us what everything is anyway. So unless it needs a special name, I don't really think that's a big deal. So dx, which is change in x, right? If you're not used to that syntax. A.x, let's do b.x. b.x minus a.x, but dy equals b.y minus b.a.y. So we've got the change in each of them. Reboot time, be right back. Yeah, see you in a bit. Points is going to have to be mute because we're about to push stuff into it. Actually, now that I think about it, the other thing we could do is collect everything, but we'll see. Dx dy will give us the change in each of them. One of these is going to be 0. And I suppose they could be negative as well, right? So if we do this correctly and we write it so that we could change both of them, it will be what? Do we need to iterate over these both at the same time? Probably. Does our input guarantee anything like that? Like, these are all straight lines, so one of them is the same. So we can probably skip that part. Although this one goes from 5, 5 to 8, 2. That's a diagonal line, isn't it? Is that supposed to be in the input? Did I mess something up? 5, 5 to 8, 2. That's not a... Each line event is giving us a line segment in the format of x1, y1 to x2, y2, where the coordinates, the line segments includes the point at both ends. For now, only consider horizontal and vertical lines. Oh, okay. So there is diagonal lines in the input, which we'll probably have to deal with in part 2, but for part 1, we don't need to. Okay. So if dx equals 0 or dy equals 0, then we continue. So that means one of these is going to be the thing. So we have bx minus ax, right? So we have 5 minus 0 in that situation, and we have 0 minus 8 in that situation. So if it's 5 minus 0, then we can do b dot x dot dot dx. And this would work. And then we would do points dot entry point x is new x and y is y. For default, what is wrong here? What is it? It doesn't matter which dot y we use. Why is that angry at me? The trait OR is not implemented for point. Okay. We can fix that. So B tree keeps things sorted, so we also need eq. Quality, partial eq. These are all totally cool because they are like points on a graph, which means they do have equality, they do have an order, that kind of thing. Can't compare point with point. Partial ORed, there we go. So I don't use ORed that much, but I think that partial ORed and ORed are the same kind of thing as partial eq and eq, where equality is a marker trait. I think ORed might also be a marker trait, and the partial equality and the partial ordering is where all the logic lives. Or default. No, then we don't want or default. We want or insert one. Okay, so basically if we have the simple case of a positive X change, right? We can start with a dot x. We go up to the change in x, which takes us from 0, 1, 2, 3, 4, 5. A dot x plus d dot x, I think is the upper bound. So we go from, in this case, 0, 1, 2, 3, 4, 5. We insert each of those. How do we... I forget what the other entry APIs are. So the entry API is really cool in Rust, actually. The entry API is kind of like a convention, if you will. I don't think it's a formalized API, but on B-tree maps and hash maps and stuff like that, you can call .entry like we do here with the key, and it will either give you the ability to insert something if it doesn't exist, or modify it if it does. Let me look up the B-tree map version. B-tree map Rust. And entry. See, so implements the entry API or insert. That's what we're already using. There are more functions here. Or insert, entry, attack. I think there's an end modify here. End modify VV plus equals 1. I think that's a valid thing. So we need to dereference V because we're changing the value underneath. Lines. Fine, we don't need the debug. So we're failing. What's the actual answer to the example? It's 5 in the example. 1, 2, 3, 4, 5. So this will be, where's our test? This will be 5. Process input. Okay, so this works for horizontal X lines. So let's do this. If dx equals 0, then we do this. Else, if dy equals 0, then we do the same thing. But with y instead of x. So we drop in our points there. And then we're not handling negatives yet, so not super worried about this, but let's do points dot iter dot But can we count for this? Filter. What do we have? Probably like point and count. And if count equals 2, we'll destructure this a bit so that we can compare. And we collect into, or let's just count. I think we can just count. Count as a U size, and we don't really care, so we'll just make it a U size. We don't really use point here, so I'll just do that. We'll debug points to see if we're actually modifying anything here. Points is empty. Let's debug A, B, dx, dy. Value used here after move. Okay, makes sense. Do these. Okay, so let's take a look at this. 0, 9, and 5, 9 results in a dx of 5 and a dy of 0. Makes sense. So that should go here. So let's do print line, inserting, yada yada. B.x, new y. Okay, so 0, 5, 5, 0, 8, 0. So this will be it. Dx is -8 and dy is 8. So we should ignore that because both numbers change. 9 and 4 and 3 and 4 is another dx. Here, 7, 0 and 7, 4 is a dy, which gives us what? Should give us 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, right? But we don't see any of that. Interesting. Did I mess up the range? Let's go check. 9.9. Did I mess up? Oh my, I put these in the wrong spot. That's what I did. This one is this one. And this one is that one. Whoops. Okay, so now we have 2, which makes more sense. We've got the line for 0 to 9. This being printed out in a nicer form would be nice. I think we have these down here. Let's see. We could basically ignore negatives by flipping them. So if we are ever at like for here, right? And do we ever have a negative y? Yeah, we do have negative y's. Do we ever have a negative y with a 0x? I don't think so. So let's get rid of a few of these debugs. We'll run this again. 70717273. So if dx equals 0, let first second equals if dy dot what does signum actually give us? Rust signum. This is a separate package. Signum. Returns a number that represents self. 1 if 0 is positive, -1 if negative, nan if the number is nan. This is also on the F64. So I'm assuming if we did like U32 or something, and we did U32 doesn't, oh right, of course U32 wouldn't have signum. Why would it have signum? 0, 1, or -1. So we can match signum 0, 1, -1, right? And then this 0, I don't think should happen. So let's do that. For 1, that means we're good. So we do it the way that we're doing it currently, which is a dot y plus dy. So we do a here, and then we do b here. Why is signum complaining? This real initialization might get skipped. Move occurs because A has type point, which does not implement copy. Value used after move at 36. We are about to change this. And then the X doesn't matter because it doesn't change. So let's do this because I don't think we'll ever get a 0. But we do have to cover, if we match this, we do have to cover all of the patterns for I32 because that's the return type. So 70717273. So we have 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. This is 7, 0, 1, 2, 3, 4. So our range has to be inclusive. So 0, 1, 2, 3, 4. And then we have maybe this one over here. So it's 0, 1, 2. Where's 2? 2, 2 to 2, 1. That would be a negative. So that should be inserted, but it's not. .21, y1. Let's do dy as well. So dy is -1. That's not... I guess we could do it that way. Right? If we always do a. I guess that doesn't matter. I feel like doing a range. Rust playground. Let's check this. Debug 0 dot dot -2. Oops. I feel like this should work, but let's do this instead. For I in 0, -2, debug I. Every time I will hit Command S for the rest of my life, even on a web page. Let's get rid of this download. Again, I did it again. I didn't even use the same hand, and I did it again. So it just doesn't work. Negative range Rust. I didn't know that negative ranges wouldn't iterate at all. So we need to keep this around. And if we're doing this correctly, or if we're doing it the way we're doing it right now, then we need to like something like that. Two, 1, 2, 2. That gives us what we need. So that works. Let's do that down here. And then these become PT. And this becomes absolute value, because we've effectively already handled it. And then our test fails because panicked at nope. We get a 0 somewhere. Oh, because we needed DX there. Okay, that works actually. That passed the test. So let's get our actual input in there. Oh, wow. These numbers are bigger than the others. Cargo run in part 1. Oh, I should have gotten rid of all the debugs. See if this is the answer. Answer is too low. So we've written something that works for the test input, but doesn't work for the actual input. RIP. I don't even know where to start. If you're stuck, make sure you're using your full input data. I'm pretty sure I am. Test input. Let's check part 1 to make sure we're pulling in the right file. We are pulling in the right file. We aren't like parsing this weirdly, are we? There's no change in the parsing. And I think as indicated here, we have all the right numbers. Let's do this. Let's do inspect v debug v, and then let's test. It passes, so we need to do no capture, which will pass a flag to the Rust compiler to tell it to actually give us the output. So if you ever are writing Rust tests and you need to see the output for like a passing test, which normally the output would get swallowed for those, you would use cargo test -- no capture. So we're left with 0, 9, 1, 9, 2, 9, 3, 4, and 7, 4. Those are the right ones for the example code. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these, then 4, 4, 1, 2, 3, 4. So that's 4, 4 that should have it. 4, 3 has it though. You know what I might have messed up? Message retracted. I feel like as a person that runs the channel, I should be able to see messages that got retracted. Okay, what did I do wrong here? This X value is not high enough is the problem. And it just happens to land on the right spot. And then this one is 7, 4. So I bet you that this is supposed to be 1, 2, 3, 4, 5, 6, 7, 8. So the X values are too low for some reason. Where's our inserting? Here we go. So we don't need this for the y's. We do need this for the x's. So we do, let's see, test input. Actually, we do need to be doing the top one, don't we? Okay, so we're here, right? And this is for when y is the same. So it's either this one. Let me pull these into a new thing and just, those are the same, those are not. Those are the same, those are not. Not. Same, not. So these are the ones that could be problematic. We have to go from 0 to 5, which we do. Then we have to go from 3 to 9, which we do. Then we have to go from 0 to 2, which we do. And then we have to go from 1 to 3, which we also do. So maybe it's the y, no. Maybe it's the y position that's off. That would be weird though, right? Because this and these two are the ones that are shifted to the left one currently. I guess this could be, this y could be in the wrong spot. Those look all right, so let's check these. Okay, 1, 2, and 0, 1, 2, 3, 4. Look at our test input. Whenever x is the same, 1, 2, yes. 0, 1, 2, 3, 4, yes. Let's do this. So this hopefully should give us just a full list of all of the insertions that we have to do. So we'll go through this one by one and we'll check to see what we're doing here. So 0 through 5 for 9. Yes. This one we ignore. Three to 9 for 4. 3 to 9 for 4. That works. 1 to 2 for 2. That works. 0 to 4 for 7. That works. 1 to 3 for, oh no, 0 to 2 for 9. 1 to 3 for 4. And then not used, not used. Okay. Oh, these are the original points. That's why. Are they? Three, 4 here, and 3, 4 here. Would be 0, 1, 2, 3. 0, 1, 2, 3, 4. Actually, they are in the right place. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4. And then 7, 4. So, dang it. Literally, like, the input, the test input and the real input are different in some way. Figuring out where they're different doesn't feel like a particularly amazing stream, so I think I'll just call it there and finish up off stream and then push the code up. Because what we're doing is correct. The input, there's something about the puzzle that they didn't say. We're not supposed to do horizontal or vertical. We're supposed to do the things that we're doing. The number of points where at least two, oh, you know what the problem is? I figured it out. Greater than or equal to 2. And this is our number. It was just an equality. Gold star. Okay, so I wish that the input was accurate. Like I wish there was a 3 in here or something. But that's not bad. Okay, we also need to do diagonals because of the limits of the mapping system. Horizontal, vertical, or a diagonal line at exactly 45 degrees. That's amazing because this would have sucked otherwise. 1133 covers 112233. 9779 covers points 9788 and 79. So we need to go from X's to Y's in diagonals. So this is part 1. I'm going to copy and paste this into part 2. Part 2.rs. Get rid of these debugs. And then basically the only thing we need to do is a new calculation, right? So change in X, change in Y. This is no longer continue. We have to deal with this now. So we've got dx and dy, which can be positive or negative. So I think we do the signum. I think we do signum, and I think we do... Actually, this will work for everything. So signum, signum, this is dx, this is dy. We have a and b, right? Here. So loop maybe not loop. What do we do here? We do... They're going to be the same number of iterations, right? So maybe we do the magnitude of the change. So for I in dx.abs, we aren't going to need I. And this is going to be 0. Then we do, actually we are going to need I. So we do let new point equal point x is going to be a dot x plus I times sx times, or plus isx, I think. So we'll start with 0, we'll go to 1, then 2, then 3. Okay, that'll work. I think this needs to be that. And then y is a dot y plus I times xy. I think that's it, right? New point is the change, and those includes the numbers. So it's either, actually, if this is 0, we already covered it, so we're good. And then we do the same thing we did here. And then the answer down here needs to be 12, I think is what it said. Protest bin part 2. That just passed. So either I messed up and I ran the wrong test, or it just works. So let's run cargo run bin part 2. And the number gets higher. And we have a gold star. So we're good. We're done. So Signum to save the day today. I don't know if we can combine these. It feels like we should be able to combine these. They do the same thing down here. This absolute thing feels a lot very similar to what we're doing down here. So maybe I'll try to modify that later. We can do, oops, that's not what I wanted to do. We can do the release builds to check out the heap. Target part 1. Oh, we need to get rid of the bugs. I mean, we don't really for the heap, I don't think, but they are definitely, are they in lib? Did I do something weird? What does Signum do? Signum will give you a 0, a -1, or a 1, depending on the sign of the value. So Signum here is we're taking the change in x, so like 9 minus 5. And when we get the Signum, this number will either be 0, -1, or 1, which you can see we use up here as well, to determine which direction we need to go, because you can only range from lower number to higher number. If you range to a negative number, you can't, it doesn't work. So you have to flip them. If it's 0, Signum comes out to 0, but since we've already identified that that is 0, I'm just incorporating that in the rest of the panic. Part one, debug. Let's get rid of this inspect. I don't think there's any others. Yeah. Let's build part 1, Part 2, absolutely massive. I think that's 2 megabytes. So a lot of work to do. I think we can get that way down. But I'm going to do that off stream because it's Sunday and I'm going to call this a short stream. So we got part 1, we got part 2. We used Signum, which was the big hang up if you are doing this kind of thing and you're trying to figure out like, okay, what order do I, how do I use range here? Signum is the answer. We also ended up using the absolute value here, but that's not as interesting. Big interesting point today is we use the entry API on a B-tree map. Oops, I deleted something. So big interesting thing today, entry API. Entry API is points.entry. You pass in the key, which in Rust for a B-tree map can be a rich struct. So we can pass in our point struct here. And because we derived equality and ordering and stuff like that, that just works. And then if we have one, we can modify it and insert another or add one to it basically. And if it doesn't exist, then we insert one as the like default value. We've seen this point kind of thing. And in that way, we can now do like a count of all of the places that we've seen multiple times. So yeah, thanks for hanging out. And if you're in Discord, let's chat about some Advent Code stuff.